Do you remember ever taking any antibiotics? Are you allergic to any antibiotics? Have you ever taken an antibiotic for an illness or an infection that didn't work? In this activity, we'll take a closer look at antibiotics and examine their effect on bacteria.
Okay, and pick somebody.
Roadside.
Alexander Fleming was a young medical researcher in 1928 when he noticed something unusual in the bacterial cultures he was growing.
Not one STD.
Salmonella.
I was 18.
You are what group?
Laura, number 5.
Okay.
It's the anthrax. It's one at the top. Looks like anthrax.
Okay, you are
Bacillus.
Chloe. Okay. I think like 2 for each group. I'll have to find it out tonight actually, but you'll get a forceps like this. You're gonna dip them in your alcohol, real simple. Just kind of do that real fast, get rid of the excess. And you guys are gonna light them on fire. Make sure it burns all the way off too. See, like that, it's still not done. There we go. And then just kind of let it cool down for a sec. And what you guys are gonna do is you're gonna have a little tube with your your antibiotics. There'll be little tiny discs. You have to pick them out with these. And the reason you're lighting them on fire each time is because we don't want any contamination, cross-contamination at all whatsoever. But do you guys need to see this again? If you don't get it to her, that's fine.
The PowerPoint didn't share.
I probably won't get to it.
And you guys start packing up at about 2:02,
Do you want me to
2:03.
make it and just share it with you guys?
Yeah.
Are we just gonna do it in this order? That's,
I guess so.
okay, like 1 slide for each.
Yeah, I don't
Depending
care
on
how you
how-
present it.
Well, the questions themselves are kind of like grouped.
Well, yeah.
Yeah, I'm not worried how you guys present it. You just have to get those concepts across to the class.
So we could do a skit.
I mean, I was gonna do.
You can do a skit.
Yeah, if
We
you
can
wanted
do
to
it,
do
you
a
can, like,
skit,
act out
I would
stuff.
definitely
We can
limit that to like 4 minutes or something. But there you go.
Like change your hats. We can have like a play, right? How there's like that narrator in the background, like saying what's going on.
Pretty much, because then I'm gonna have a representative from each of your little groups. That's why I wanted you guys in groups. Feel free to come get an equal eye and be serious right here.
Be serious?
Yeah, Bacillus cereus. That's the other bacteria. You guys
I thought you were messing around, just like.
Yeah, be serious, guys. Now. Yeah, you guys can get started. That should be the first step in the lab, pretty much, because then I'm gonna have a representative from each of your little groups. That's why I wanted you guys in groups. Feel free to come get an equal eye and be serious right here. All right.
How come you can't touch that?
Can I touch the bottom of it? Okay. Like, can I?
What's that for?
I think you put it in there. Okay.
Did we write our names on this?
Yes, I did. Do you guys want to open one? Can we open it? Okay. How do I open it? I think you just take off the lid. And then we just put it.
Wait.
Okay.
We don't really need the first
No, we don't. But it was fun to do.
You can probably turn the Bunsen burner on. I know, because. No.
No, because we have to still as we get after that. So now what are we doing?
So place the control disc in the center position.
Make sure you, hey, everybody,
Control.
take.
Are we doing all of the bacteria for each group, or is it just one group, just one bacteria?
No, you have each group has
Antibiotic.
2 bacteria. They have each have 2 different bacteria in it.
Yeah, I meant antibiotic.
Yeah, you guys are each going to go around, and you'll eventually have 6 different antibiotics and 1 control. And I'll put the controls over there.
Do you think One, I don't know how to take it out.
Well, first of all, we're supposed to get the control first. It doesn't.
We're all like, yeah, what is
figure it out.
this?
You really do have to
Good thing you have gloves on. Open. Taylor, open this. I'm afraid to open it. Why? She's bacteria.
Wait,
Wait,
shouldn't it be the other?
which way is it supposed to be?
It should be on the side with the augers. So. That side.
Here, we need to set that down.
And it stinks.
Yeah, just put the equivalent further back there. So where'd you go for that?
This is unnerving.
Right?
Effectiveness of different antibiotics against different types of bacteria.
Say that again?
The point of the lab is to demonstrate how bacteria hold up against different antibiotics.
And how are you going to test that?
By using 6 different antibiotics in an agar plate culture of E. coli. And for ours, it'll be, we're doing Staphylococcus.
How will you know if the bacteria is antibiotic resistant?
If after a time it starts to not die when it's exposed to the antibiotic, then you can tell that it's developed a resistance to it.
I was supposed to push it
What
down.
will that look like on your plate?
No, just leave it on. Yeah.
It would look like it would be killing or destroying the antibiotics. So,
Oh! I'm not using that.
If it kills the bacteria, what will it look like?
I actually don't know.
Oh, there'll be a zone of inhibition around it.
Oh, yeah. There will be a ring around it or an oval
Yes.
sort.
Dear God, that
Be
would fail
clear
to
of
get
bacteria.
Are there any conclusions you guys can draw based on your data so far?
No. No, I can't.
Some antibiotics work faster than others.
Which ones?
So far, tetracycline and cephalosporin.
Okay. And how do you know they're working more effectively than the others?
Keep all the bacteria away.
Are you guys
Circle.
getting it or needing any help, questions-ish?
Penicillin is 1 millimeter.
1 millimeter.
Yeah.
Do you guys draw any conclusions so far from your data?
We can conclude that TE30, I'm not sure what the name of the antibiotic is, but the disc code is TE30, has the highest efficiency? Yes, that's it. I couldn't think of the word.
For both bacteria?
It seems like it so far. We are
Well,
still
C30
measuring the
has
ones for...
11. Yeah, C30 is pretty close for both of them.
I thought C30 had 1.1.
Can you guys draw any conclusions from your data so far?
Well, maybe not very good ones. The ones, antibiotics that are working the best are pretty obvious so far. Like the cephalosporin is the best one for B series, but our E. coli one's kind of spotty, so it's hard to measure that.
And how do you know they're working?
Because on this one, the bacteria is all over, but where the antibiotic is, there's a big circle where it's not, the little yellow dots. And like the bigger the spot is, the better it's working, because that means that the bacteria is not able to grow there.
And your exit is going to be the same. You know, you're going to tell me something that you learned from the presentations, and you're going to give them some feedback. And so other than that, I'll give you guys a second to write that down, and we'll get started.
The typhoidal salmonella is contacted through direct contact with infected fecal matter of a person that has the bacteria in them.
Which we don't understand what that means, obviously.
Hello, we are the 3 T's, Taylor, and Trevor, and today we will be presenting Staphylococcus aureus.
I did our project on Escherichia coli.
Well, basically what E. coli is, it is a gram-negative rod-shaped bacterium that is found in the lower intestines of a warm-blooded organism or an endotherm. It is a frequent...
Go up, don't let go of it though, it will snap off and fall on your head. Okay? Okay, I need you guys to turn the lamps off too, please.